heavy chains que le había dicho, ¿se acuerdan? El mu chain, el epsilon chains. Hablamos nosotros de que existían varios tipos, ¿verdad? ¿Se acuerdan? Con referencia al heavy chains, reciben los Greek names. You have the epsilon, the mu change, the alpha change, the gamma change, right? All right. Those are the ones. With regard to the alpha change, we said, and we find that on the chromosome 14, right? And then we said the light chains will contain two, which will be the kappa and lambda. You go for this one again, kappa and lambda. So you find kappa in chromosome 2 and lambda in chromosome 22. Right or not? That will correspond to the light change. And then you have the FFB fragments. Usually we're going to be talking about that with papain and pepsin later on. All right? The effect that it will have with that. Where the antigen have to go is right here, and where the cells with the FC receptors will come right here. Complement with regard to IgG will come right here, and with regard to IgM will go to the constant heavy 2, constant heavy 4 domain. Here is what we call the hypervariable regions. We were talking, remember? Those are very important because those are the ones that will give you the specificity, again, a specific antigen binding site. You have the N-terminal, and here is your carboxy terminal. All right? So here is where you find the three-dimensional structure of variable domains. You try to explore those things, and you're going to look for these little loops right here. Every time you know those loops, those will be considered to be part of a sequence of amino acids that will be specific for those antigens. Okay? We call the FR domain. Oh, here also. An antigen binding site is made up of 6 hypervariable loops. 3 in the heavy change and 3 in the light change. All right? And then we were talking about the classes of human immunoglobulin, and we went over all these subclasses. All right? You have the IgG. IgG will have how many subclasses? 4, right? And then I told you, remember where you're going to find those most commonly. That's the IgA, that's the IgG, mu, and delta, right? But we're going to start with IgG. Aquí le faltó a esta nota lo de los allotypes, isotype, and all right? We're going to put that later then. All right, let's go with the IgG now. All right, well, what did you remember from IgG? Ponle busca si tiene esa, donde estaban todas las inmunoglobulinas. Hay un cuadro que te dice todo eso, Alex. Don't worry if you don't find that, man. Pero ahí está. Hace mucho más ruido que a veces la... Déjalo ahí, no vaya eso, entonces, para que ellos vayan ya. All right. IgG, then we said that was the dominant antibody in any type of internal secretion. Yes or not? What was the dominant antibody in, for example, in the respiratory tract or mucus type of secretion? Remember that. And then you have to know which of the IgA, the dimer form, the monomer form, or the trimer form. All right. Monomer you will find where? All right, very good. That's most commonly. So this is the most common found in secretions like blood, CSF, lymph, etc. Internal secretion. We said that they have a variable regions close to the amino terminal. Si tienes un IgG, estaría bueno una inmunoglobulina. A change from that one. All right. Si tienes o no. Cualquier inmunoglobulina, no pienses mucho.